Now, here we have a lithium atom. And if you remember from our ions, that this lithium atom, it's only got one valence electron, and it's going to lose that valence electron. When it does that, it's going to have an empty valence shell. And because now it has more protons, 1, 2, 3 protons, than electrons, 1, 2, and because protons have a positive charge, that lets us know that metals form positive ions. Here we have an example of an oxygen atom. We can tell it's oxygen because there's 1, 2, 3, 4, 5, 6, 7, 8 protons, and oxygen is atomic number 8 on the periodic table. And so remember that these nonmetals, they will usually gain, so here this oxygen gained 1, 2 valence electrons, and that's so that they can have a full valence shell, right? So we can see here that this this orbital is full of electrons. And because they're gaining electrons, right, and so this atom has more electrons than protons. It has 10 electrons, but only 8 protons. Because it has more electrons than protons, and electrons have a negative charge, nonmetals form negative ions. And so remember that metal ions are positive, right? Because when you lose electrons, you form a positive ion. And that nonmetal ions are negative, right? Because when you accept electrons, you become a negative ion. Those positive metal ions and those negative nonmetal ions, they're attracted to one another. And the reason why they're attracted is because they have opposite charges. So whenever you have two things with opposite charges, they're always going to be attracted to each other. It's kind of like two magnets being attracted to each other, right? Like the north end of one magnet being attracted to the south end of another magnet. They're opposites, and those opposites attract. Okay, so let's go through some examples. What we're going to be doing for examples today is drawing Lewis dot diagrams and determining the formula of the ionic compound. So before we do that, I'm just going to show you some models. And you don't not have to write this down, so don't write this down. So we're going to start off with the ionic compound sodium chloride. So we've got sodium here. Draw a sodium atom, or I have drawn a sodium atom on the screen. Remember, it's got one valence electron. And then here we've got a chlorine 35 atom, and it's got 1, 2, 3, 4, 5, 6, 7 valence electrons. Okay, so our sodium atom is going to donate its electron to the chlorine atom. Right? So the sodium atom is going to donate its electron, so it gets rid of it. So you can see we don't have the electron here anymore in this picture. So that its outer orbital is empty. This whole outer orbital is empty. Right? And that makes the atom more stable, so that's why it donates the electron. So then similarly, the chlorine atom accepts that electron, right? So we can see in the new picture now, we've got an extra electron with this chlorine atom, so that its outer orbital is full. And so this becomes an Na plus ion, right? Remember, metals form positive ions, and that's because it got rid of one electron. And this forms a Cl minus ion. That's because this chlorine atom accepted an electron. And when you get an extra electron, you'll form a -1 charge. And then again, because these two atoms have opposite charges, they're attracted to each other, right? The ions are attracted to one another because they have opposite charges. And so we ended up with an NaCl molecule, right? That compound forms because those two ions are attracted to one another. Okay, so we're going to do a similar sort of thing here, right? We already know what our final answer is going to be, NaCl. But we're going to show how we develop this formula using Lewis dot diagrams. Right? So first thing we're going to do is we're going to draw the Lewis dot diagram for sodium. Na. We'll put a little box around it. This is something that I didn't teach when I was doing Lewis dot diagrams, so I'm hoping to do a little bit of reteaching on how to do Lewis dot diagrams right now. I think a lot of you are really struggling with how you're supposed to organize the electrons around the atoms, and so I'm going to do a little bit of reteaching on that right now. What you should really think of is the atom has a box around it. I think that'll help you with how to organize the electrons. Okay, so let's take a look at sodium on the periodic table. It's right here. You can see it's the first element in its row. And so for that reason, sodium is going to have one valence electron. Okay, now let's take a look at chlorine. And again, we're going to put a box around it. Chlorine is right here. It's the 1, 2, 3, 4, 5, 6, 7th element in its row. So we're going to put 7 valence electrons around it. Okay, so here's 1, 2, 3, 4, 5, 6, 7. Now, I want to go back real quick here. When you're doing this, each side should get 1 electron before any side gets 2. So let's just go through that one more time. This side gets 1, this side gets 1, this side gets 1, this side gets 1. So we're at 4. Remember, we're trying to get up to 7. Now you can start giving sides 2 electrons. We'll give this side 1 electron, this side 1 electron, this side 1 electron. Okay, and now we're up to 7. So both sides have the right number of electrons right now. So that's your first step, is you're going to draw the Lewis dot diagrams. Alright, then you're going to go ahead and give the electron, donate this electron over here. So then when we redraw it, it'll look like this, with this 1 electron having migrated over here. Right? There's only 1 sodium atom, there's only 1 chlorine atom, so then we write the formula as NaCl, magnesium fluoride. So we're going to look up magnesium on the periodic table. Draw it right here, Mg with the box around it. Mg's right here, it's the first, second one in its row, so just like calcium, it's going to have 1, 2 valence electrons. Next we'll look up fluorine. So again, F with the box around it. Fluorine's right here, it has 1, 2, 3, 4, 5, 6, 7 valence electrons, so we're going to give it 7. Now remember, when you draw these, you go 1, 2, 3, 4, 5, 6, 7, right? And so then what's going to happen is, since magnesium is the metal and it wants to have an empty outer orbital, it's going to donate 1 electron. It's going to donate an electron here. But what about this other electron? Where can it go? It can't give it to this fluorine atom, because this fluorine atom would already have a full valence shell, right? Already have 8 electrons in its outermost orbital. So where's this other electron going to go? Well, what we're going to do is we're going to draw another Lewis dot diagram of fluorine over here. So it should look pretty identical to this one over here. And it's 1, 2, 3, 4, 5, 6, 7 valence electrons. And now this electron is going to get donated to this fluorine over here. So I drew it in a different color because it's going to a different atom. And so what does that final picture look like? Well, we have that first blue dot moved over here. Second blue dot moved over here. Right? We can see this fluorine's got a full valence shell, so it's happy. Magnesium has an empty valence shell. And then this fluorine atom right here has a full orbital, so it's happy. Okay, and so then how do we write our formula? Well, it's got 1 magnesium ion and 2 fluorine ions. So the way we'll write it is MgF2, since there's 2 fluorines. And again, the reason why this atom had to have 2 fluorines is because we had to have 1 spot for this electron to go and 1 spot for this electron to go. All right. Okay, so up next we're going to do potassium phosphide. Examples here, we're going to start off here with aluminum sulfide. I've already written the chemical symbol for aluminum and put a box around it. Let's take a look at the periodic table. Aluminum is the first, second, third element in its row. And so we're going to give it 1, 2, 3 valence electrons. And then we'll add a sulfur. Sulfur is the first, second, third, fourth, fifth, sixth element in its row. So we're going to give it 6 valence electrons. Okay? Remember that the metal always donates to the non-metal. So we'll donate 1 electron here. And then we'll donate this electron over here. But now sulfur's full. It can't take any more electrons. But aluminum still has 1 more electron to give. So again, just like before, we're going to fix this by adding another sulfur ion. So we'll draw another Lewis dot diagram for sulfur over here. Okay, then aluminum can donate its last electron right here. But now this sulfur atom isn't full. So how do we fix that? Well, now we've got to draw another aluminum with 3 dots around it. 1, 2, 3. And then this aluminum can donate one of its electrons over here. But now this sulfur atom's full. So now how do we fix the problem of these remaining 2 electrons? Where are they going to go? Well, we're going to need to draw another sulfur atom. Okay, so now we've got a sulfur atom with 6 valence electrons. We'll donate 1 electron here and 1 electron here. And now all the aluminums are going to be empty of electrons, right? They'll have given away all their electrons. All the sulfurs are going to be full with electrons. Their outermost orbital is going to have 8 electrons in it. And so we can redraw the picture here. Here's the 2 aluminums. They're empty. Here's our 3 sulfurs. They're full with electrons, right? Each one got 2 blue electrons from those aluminum atoms. Okay, so then when we write our chemical formula, there should be 2 aluminums and 1, 2, 3 sulfurs. And that's what we see over here, Al2 and S3. Okay, one final example, magnesium nitride.